अच्छा, so the quick recap is के factors को छोड़ो, we did successive ionization energies and we did ionization energies down the group. This is size of atoms. Ionization energies was right at the bottom over here. So down the group, I told you when you move down the group, the atom becomes bigger. So removing the electron becomes easier and easier as you go down the group. Why? Because the atom becomes bigger, atomic radius increases, the electron is further away, and the shielding increases. So two factors, they say that it's becoming easier to remove electrons. One of the factor actually opposes that, and that is that when you move down the group, the nuclear charge or the number of protons over here in the nucleus, they continue to increase, which is why there should be more attraction. But because of these two factors, the attraction is actually lesser down the group. Achha, when we move across the period, the distance, the shielding remains constant. You have the same number of shells. You're trying to remove electrons from atoms across the period, but the protons gradually increase. Lithium over here has 3 protons, but fluorine on the other side has 9 protons. Okay, they gradually increase. So because the protons are continuously increasing, it's becoming harder and harder to remove electrons. 9 protons will attract electrons with a lot more strength. 3 protons will not attract the outer electron with enough strength. So it's easier to lose electrons. It's much harder to lose electrons over here. And the distance also slightly decreases because there's more attraction. So the electrons or the shells, they become closer and closer to the nucleus. Okay. And then I told you that there's going to be dips. It's not going to be a direct increase. What will happen is that there's going to be a dip at group 3 and there's going to be a dip at group 6 when you move across the period. Or group 3 mein tha ke, why is there a dip at group 3? Because all of a sudden you were removing electrons. One second. So all of a sudden you were removing electrons from 2s subshell, but when you move to boron, you're now removing an electron from the 2p subshell. So there's an extra subshell, which leads to higher shielding. So it kind of becomes easier to remove electrons in this case. The electron is slightly further away in boron. So slightly easier to remove electrons, it's more shielded, and you're removing it from a higher energy p subshell. So that's why there's a slight decrease at boron. And then you have another dip at group 6. Why do you have a dip at group 6? Because in nitrogen, you were removing electrons from the 2p subshell. In oxygen, you're still removing electrons from a 2p subshell. But this 2p subshell is paired, which means that nitrogen case where everyone had 1 electron, there was no repulsion. They were all electrons on separate axes. But now you've got 2 electrons in the same subshell. So that means it kind of becomes easier to remove electrons because the electrons are repelling each other. And that was the explanation for that. Achha, but anyways, moving to the questions now. और ये पे discuss करते रहेंगे. Let me just open a pure table. Yes, I will, Zabiba. Okay, but what I can do is we can read an extra class sometime, okay, to go over this, because the next chapter would be kind of dependent on this, the whole atomic structure chapter. So starting with the first question, which element has the second smallest atomic radius in its group? I mean, that's the first part. So you're looking for an atom that has the second smallest atomic radius in its group. So we can arrange a class. So this one, second smallest atomic radius in its group, second smallest. Remember, he's talking about within a group. So who's got the smallest radius? It's the top ones. Lithium has the smallest radius over here. In its group, the second smallest would be sodium. If you're talking about group 2, then the smallest is beryllium. The second smallest would be magnesium. So that basically means you're talking about period number 3 elements. Not in the case of noble gases, the second smallest would be neon. But in all the other, because they don't, I mean, the group starts over here, fluorine, the second smallest would be chlorine. So is this clear that we're talking about these period 3 elements? Okay, you clear?
जी sir.
Achha, so over here we're talking about period 3. Achha, we're talking about period 3 elements, and achha, and the third lowest first ionization energy in its 1 second. Achha, and the third lowest ionization energy in its period. So we're talking about period 3. So what are the elements in period 3? The elements are sodium, magnesium, aluminium, silicon. So it's either one of them. So it's either going to be sodium, magnesium, aluminium, silicon, phosphorus, I guess. Then what's group 6? Sulfur, Cl, and argon, right? So that's your period 3. And he's talking about the first ionization energies. What happens to the ionization energies across the period? They increase. Then there's a dip at aluminium. Then they continue to increase. Then there's a dip at group 6. And then you have chlorine. And then you have argon. Okay? So that's how across the period the ionization energies look like. Now he's talking about the third. So he's talking about the third lowest first ionization energy in its period. So third lowest, who's got the third lowest in the period? This is the lowest, right? So this is the lowest, right? The first lowest. This one over here is the second lowest. I mean, if you look at it vertically, that's the second lowest. Which one is the third lowest? The third lowest happens to be this one. You can look at it in a vertical direction. Like the smallest ionization energy is for sodium. The second lowest is aluminium. The third lowest is going to be magnesium. So magnesium is going to be your answer. So I'm going to repeat the question. The question was that it should be the second smallest atomic radius. So when I looked at the period, this is the second smallest. It's either sodium, magnesium, second smallest in its group. So if you pick any group, the second smallest is going to be the one that's the second atom in the group. Fluorine is going to be the smallest. Chlorine is going to be the second smallest. So we're talking about elements in period number 3. And I plotted all the period number 3 elements. And then he started talking about it having the third lowest first ionization energy in its period. So I plotted the ionization energy in the period. And the third lowest came out to be magnesium. So you clear? Is this question clear?
Sir, I'm still confused on how it was a period 3.
Because it was the second smallest atomic radius in its group. In the group, okay, group. Let's talk about group 1. Who's the second smallest? Sodium hoga na? Abdullah, is that clear?
Sodium. Yes. Yeah.
If you're talking about group 2, which one is the second smallest? It's going to be magnesium, right? So basically, he's talking about the element belongs to this any one of these, right? Either aluminium, so it's one of these, right?
Oh, I see.
So that's how we figured out that it's going to be period 3. And then he talked about it having the third lowest ionization energy in its period. So I knew it was a period 3 element, and then I looked at the period 3 sketch, and this is how the sketch looks like. Okay. And the third lowest ionization energy in its period. The third lowest, this is the lowest, this is the second lowest, this comes out to be the third lowest. But this is the fourth, this is the fifth, sixth, seventh, eighth. As I'm moving to the next one, this one is also slightly difficult. It says that there's an element X and it has a higher first ionization energy than Y. So first thing, X has higher ionization energy than Y. So let's try and test this statement out. He's asking what could be X and Y. So ignore the rest of the question. Let's just first eliminate some options. So I've got carbon and I've got boron. So X should have the higher ionization energy. That's the first requirement, right? So I've got carbon and I've got boron. So what will it be if I go and have a look? Here's carbon and here's boron across the period, right? So it's you're at group 4, right? So if I sketch across the period, it's going to look like this. It's first group, second group, third bit dip, fourth, fifth. On group 6, there's going to be a dip, and then 7 and 8. Now carbon is over here and boron is in group 3, right? So the first statement is correct. Carbon does have a higher energy compared to boron. Is that clear?
Yes.
Achha, so I'm just checking the first statement out, right? So magnesium and aluminium. So are they in the same period? Magnesium is over here and they are in the same period. Aluminium is over here. So across the period, what will happen? So what will happen? Magnesium will be over here in group 2 and aluminium will be at group 3, right? So magnesium will have a higher energy compared to aluminium because at group 3 you're going to have a dip. Okay, that's also across the period. It's a different period, but magnesium then aluminium there's going to be a dip. You be clear? Is that clear that magnesium has a higher energy?
Yes.
As the next one, oxygen and nitrogen, they're also in the same period. Oxygen is over here, nitrogen is over here. So oxygen, nitrogen is over here in group 5, and oxygen is over here. Now, oxygen is going to have a lower ionization energy, not a higher ionization energy. So that means this is not true. Oxygen at oxygen at group 6, you're going to have a dip. So oxygen will have a lower ionization energy compared to nitrogen. So that is not correct. So C gets eliminated. What about D? Oxygen and sulfur. That's going down the group, right? It's oxygen is over here, and sulfur is over here. So you're moving down the group. What happens down the group? Okay, you got oxygen, you got sulfur. Oxygen is down the group, ionization energy decrease. So this is going to have a lower ionization energy, and this one is going to have a higher ionization energy. Smaller atoms, more difficult to remove electrons, right? When you have smaller atoms and less shielding, the electron is closer to the nucleus. Bigger atoms, they've got more shielding. The electron is further away from the nucleus, so there's less attraction. So easier to remove electrons. So this is also true. Oxygen is going to have a higher ionization energy compared to sulfur. Is that clear?
Yeah.
So C gets eliminated. Now he says that 2 students states what they believe is one factor that helps to explain this. Like, so we're looking for the explanation now. Why is this higher why is X higher than Y? So the students are trying to figure out why. So the first one, let's talk about student 1. The first one states that X has a higher ionization energy than Y because an atom of X has more protons in its nucleus than an atom of Y. Now, is that true? Now, moving across the period, when you move across the period, as a one by one, let's talk about the first option, carbon and boron, right? Carbon is over here and boron is over here. Why do ionization energies increase across the period? Because you've got more protons, right? So student 1 appears to be, इसके आगे लिख लेते हैं. So student 1 explanation is fine for option A. Student 1 is correct, right? Because moving across the period, you got carbon, you got boron over here. So you got more protons, which is why it's harder to remove electrons from this one. ठीक है, ये भी clear that student 1 is correct for option A. Is that clear?
Yeah.
So now student 1 is not correct for option B because aluminium, there's a dip, right? Magnesium actually has a higher ionization energy. So student 1 is not correct because this dip is not following the trend. Aluminium had more protons. Aluminium should have had a higher ionization energy, but there's a dip now. So that means and we did do the reason for that. Kya reason se uske liye? Just a second, let me put it. The reason for that was as a reason for the dip was so here's why is there a dip at group 3? Because all of a sudden you start removing electrons from a subshell that's slightly further away. So it kind of becomes easier to remove electrons. So protons was not a reason for this. So if I go back to the question, magnesium having a higher ionization energy compared to aluminum was not because magnesium had more protons. It actually had lesser protons. So you clear that student 1 is not correct for option B. Is this clear?
Yes.
Yes, sir.
As the next one, Ajo. So why is oxygen having a ionization energy greater than sulfur? Again, it's not because of more protons. It's actually because sulfur is bigger in size, and down the group, what happens? Sulfur is bigger in size. So why did sulfur have a lower ionization energy? Or I mean, what was the reason why oxygen had a higher ionization energy? Because it was smaller, and it was more shielded as well. Sorry, less shielded. Smaller means it has fewer shells, so the electron is very close to the nucleus. So it was less. As it was kind of less shielded as well. So smaller and less shielded. So that's the reason. Not protons, right? So student 1 appears to be incorrect for this one as well. Remember, down the group, it's not protons. TK. It's the ionization energy is decreasing because the atoms are becoming bigger in size. So let's talk about student number 2 now. As I remember, this is a very layered question. TK. It's got a lot of layers on it. TK. It's you have to. So we're done with student 1 analysis, right? We're now going to focus on student 2. Student 2 comes up with his own explanations that he says that X has a higher ionization energy than Y because X has a smaller atomic radius than Y. So student number 2 is correct for the first option. Because what happens when you move across the period? What happens is, what happens when you move across the period? The protons are increasing, but the atomic radius is also slightly decreasing. They become smaller and smaller when you move across the period. So that means carbon or boron ke case mein, you got carbon, you got boron. Carbon not only has more protons, but it also has a slightly smaller atomic radius. So that means student number 2 is also correct for this one. Acha, what about this one? Why was it harder to remove electrons from magnesium? Was magnesium smaller? No, magnesium is not smaller. Across the period, aluminium is the one that's smaller. You can remember this, that when you move across the period, the atom size gradually decreases. So aluminium in group 3 and magnesium over here, aluminium is the one that's going to be smaller because aluminium has more protons. So the attraction is going to be, the electrons would be closer to it. So size wali baat jo hai na, that's going to be incorrect for this one as well. So why did oxygen have a higher ionization energy compared to sulfur? Because it was smaller. So that means student number 2 explanation that it was smaller, that's correct for this one. Okay, so the explanations for student 1 and student 2 were correct for option A. The explanations were both incorrect for option B. Even though option B was correct, it was higher, but both explanations were wrong. And the last option was that to explain this one, student 2 was correct, student 1 was incorrect. So are the explanations clear that we tried to match the explanation why the first one had a higher ionization energy compared to the second one? Is this clear?
जी sir.
Yes, sir.
So final answer, only one of the two students is correct. So what could X and Y be? So whereas only one of the two students is correct, that's going to be option. That's going to be option D. Okay. In the first one, both student explanations were correct. Like you're moving across the period, carbon, boron, both of them were correct. That not only does carbon have more protons, but it also has a smaller atomic radius. So both statements were correct for the first one. For the second one, both statements were actually incorrect. Okay, the explanation for aluminium's dip was about subshells. It wasn't about protons. It wasn't about the size of the atom. The reason for the dip, or the reason why magnesium had a higher ionization energy, was because of the subshell. There was one extra subshell in aluminium. So your dips, Joanna, these are caused by subshells, and only in the last one is only one of the students correct. That oxygen has a higher ionization energy. Why? Because it is smaller in size. It's less shielded. The protons are actually lesser in oxygen, but since it's smaller in size, there's more attraction. Okay? So the answer is D. Is that clear? This one was a very tricky question. Okay? It had many. I mean, I had to check the options in many ways. Okay? But is the question clear?
Yes sir.
Yes, sir.
I said next one is the definitions of many chemical terms can be illustrated by chemical equations. Which term can be illustrated by an equation that includes the formation of a positive ion? So first ionization energy is the formation of a positive ion, that you got X. It turns into a gaseous ion and loses one electron. So there is a positive ion. The other two we haven't really done the other two. ठीक है, वैसे इसका मैं लिख देता हूँ, लेकिन we just did the first one. I said next one. Okay, the relative ionization energies of 4 elements with consecutive atomic numbers below 20 are shown. So consecutive atomic numbers. One of the elements reacts with oxygen to form a covalent compound HX. I said now, this is consecutive proton numbers, right? So what happens, how does the graph look like across the period? It's, you got group 1, 2, there's a dip at 3, then you have 4 and 5, and then there's a dip at 6, then you're going to have 7 and 8. What happens after 8? You move to the next period, and the whole trend starts all over again. Okay, यहाँ पे ना, there would be this one. I mean, this is group 1. Then you have group 2, then there's a dip at group 3, right? Then you have group 4 and 5. Then a dip at group 6 again, and so on. So maybe you had transition metals in some of the periods as well, but the trend was actually the same. So what happens? So and this is consecutive proton numbers, right? One after the other. Then the next period starts, then the next period starts, right? So which section of this graph is actually shown? This one. This is the section right at the end. It's the point where you reach the end of the period, and then the next lower period starts. It's this section. So this was group 1. This was group 2, group 3, and then group. And then the next period starts. Okay. So you clear what this section belongs to? This one. It's this part, right?
Yeah.
So this is actually group 7. This is मतलब उसको 17 कहते हैं, ठीक है? This is group 18 or group 8, and this one is group 1, and this one is group 2. Achha, so he says one of the elements reacts with hydrogen to form a covalent compound with the formula HX. So which one of this element is it? A, B, C, D में से कौन सा होगा? Who forms a covalent compound with the formula HX?
C sir, C.
C.
Covalent. ठीक है, C Like if C, why would C will not form it?
No, it's A because in Korean they are both non-metals, right?
क्या होगा? A.
Yes. It's
A.
Give an example is
Both
HCl.
non-metals.
Remember the focus was on the word covalent, right? This is group C, it's a group 1, it's a metal. So metals don't form covalent compounds. Okay. As the next one, so clear a question, this one.
Yes, sir.
That's the next one. You've got X is an element that has its outer electrons in the fourth principal, but it's in the fourth period, right? And it has a higher ionization energy than calcium. So this means it belongs to period number 4, right? So if I open the period table, period number 4, it's this one. Now calcium is over here. That's group 2. So that's calcium. There's going to be a dip at group 3, so that's gallium. उसके बाद फिर increase होती जाएंगी. So all of these elements across the period, when you move across the period, they're going to have ionization energies that are going to be greater than calcium. Is that clear? That
Yes, sir.
bromine and etc. All of
Yeah,
these
sir.
will have ionization energies greater than calcium. So bromine is one option. That's correct. Krypton kisme, which so we've got krypton. Krypton is going to be right at the end. It's going to be right at the top. So that's krypton. So what about xenon? Xenon will have a lower ionization energy compared to calcium. The first thing, the reason xenon is wrong is that it's not in period 4. It's not in period. It's not in period 4, that's it. So you will apart a second. So I think this was potassium. This was calcium. Or then there was a dip. I think this was the group 3. And then you had 4 and 5, and there was a dip at 6, and then you had 7 and you had 8. So bromine was kind of over here. Krypton was right over here. Or xenon jo tha, that wasn't even in period 4. They can't get question. Yep, this one. As a xenon was not in period 4, it had to be in period 4. So you're done, we're done. Clear?
Yes, sir.
It's a agla part, I guess this one. So which statement where the elements are correct? P and X are in the same period. So P and X, where is P and X? Are they in the same period? P and X. Here is the answer.
No.
They're not. They're in different. I mean, these are all of these are in the same period. All of these are in the same period. They're in 2 different periods, right? So the first option, they're in different periods, right? Second one, the general increase from Q to X is due to increasing atomic radius. So the general increase from Q to X is because you have more protons, and that when you move across the period, you've got more protons. So that is correct, right? So B is correct. A small decrease from R to S is due to decreased shielding. R to S.
Sir.
हाँ.
Sir, Q to X तो atomic atomic radius increase कर रहा है. Proton numbers का तो नहीं कहा है.
Q to X, हाँ ये general नहीं Q to X across the period जा रहा है ना. So what is happening के protons increase होते जा रहे हैं. Main मैंने कहा था factor यही है. और atomic radius slightly decreases.
जी सर, लेकिन मैंने लिखा है due to increasing atomic.
अच्छा हाँ, मैं गलत पढ़ रहा था. वो तो उल्टा decreasing atomic radius है. ठीक है, so let's correct that. Increasing is wrong. ठीक है बिल्कुल सही है. Achha, the small decrease from R to S is due to decreased shielding. R to S. Why is there a dip at group 3? The reason you get a dip at group 3 is because of more shielding. Okay, boron ke upar na number of subshells they increase. You have you have more shielding in boron. That's why it's slightly easier to remove electrons. तो ये भी गलत है. ठीक है, decrease shielding, it's actually more shielding. Achha, the small decrease from U to B is due to U to B is this part. It's group 6. He gets the dip that happens at, and this statement is correct. Okay, the reason nitrogen से oxygen पे जाते हो, when you move to group 6, why is it easier to remove electrons? Because all of a sudden you have 2 electrons in a, all of a sudden you've got 2 electrons in a p subshell, and it's paired and they repel each other, so it kind of becomes slightly easier to remove electrons. So see ये वाला part.
Yes.
अच्छा, the properties.
सर ये एक क्वेश्चन है सर, ये स्पिन पे रिपल्शन ग्रुप 2 में कंसीडर करके इसके आयनाइजेशन एनर्जी क्यों डिक्रीज करते हैं?
नहीं, कि ग्रुप 2 में क्यों नहीं होती स्पिन पे रिपल्शन?
सर नहीं होती तो होगी ना, तो इसलिए तो आयनाइजेशन एनर्जी डिक्रीज होना चाहिए.
नहीं, लेकिन असल में ना वहां पे स्पिन पे रिपल्शन, the reason you're comparing it, spin pair repulsion is not a big factor. ठीक है, the reason you're comparing it क्योंकि subshells identical हैं, they're exactly the same for nitrogen and for oxygen, right? यहाँ पे तो subshells ही different है ना. So what happens is कि इसका इलेक्ट्रॉन जो है ना वो दूर चला गया ना, it's more shielded. It's the nucleus और उसका जो outer subshell है ना, उसके बीच में you got more subshells in between. So shielding is a much more important factor. ठीक है. तो स्पिन पे रिपल्शन इतना बड़ा फैक्टर है नहीं. वो उधर वो काउंट इसलिए कर रहा था क्योंकि the subshells were exactly the same in both cases. अच्छा, अब ये कि अच्छा, which property is smaller for chlorine than for bromine? Now you down the group as Cl and bromine, right? तो smaller for chlorine, ionization energy जो होगी ना वो तो इसकी higher होगी. The smaller one is going to have a higher ionization energy. So he's looking for, it should be smaller for chlorine. So B is definitely not true. अगर solubility याद है ना वो भी ज़्यादा थी उसकी. D we haven't really done D में वैसी mark करो. लेकिन B clear है कि B is wrong, right? Okay, we just focus on B. Achha, so this one. Which of the elements sodium, magnesium, aluminum? So this is pH3, the entire pH3. So we keh raha hai, has a lower first ionization energy than the preceding element in the periodic table. Preceding element, it should be lower than the preceding element. Now this is across the period, right? So this is group 1, 2, 3, 4, 5, 6, 7, and 8, right? This is how it's going to look like. Or sodium se pehle kaun hota hai? Sodium se pehle, I guess it's neon. So neon would be somewhere over here. Okay. So this is sodium. So sodium has an ionization energy that is lower than the preceding element. That's true. Okay, you can have aluminium. That could be an option because aluminium has an ionization energy that is lower than the preceding element. Or it could be phosphorus, sulfur. Sulfur could also be a candidate, that it has an ionization energy that is lower than the preceding element. Pehla part clear hai कि it's either Na, Al or sulfur. Is that clear?
जी सर.
फिर अगला part है कि he's saying it conducts electricity, so it's going to be these two. So they conduct electricity. And then he says has an atomic radius which is lower than the preceding element. And that would leave you with Al. Okay, across the period, what happens? That the atomic radius decreases. So aluminium is going to be smaller than the one before that, which is magnesium. Across the period, atomic radius decrease karta hai, theek hai? So this statement will be true for aluminium only. Conduct electricity to ye do. Sulfur is eliminated automatically. that it does not conduct. And preceding element, it should be smaller than the sodium is going to be bigger because sodium has 3 shells. उससे पिछला जो है ना neon, that's got 2 shells. So sodium is going to be bigger than the preceding element. So sodium gets eliminated. Sulfur gets eliminated, and sodium, because it's bigger than the preceding element, it's got 1 extra shell. Aluminium is smaller, so the answer is going to be A. You be clear? Did you get this question?
जी सर.
So make sure you practice a lot. Okay? Remember the theory part, that's very easy. It's very simple, but the questions are kind of very layered. They've got, they'll be dealing with a lot of things at the same time, and you have to learn how to actually solve these questions or comprehend these questions. Okay? That's more important. So make sure you practice more of these. ठीक है, चलिए ठीक है, ये कल कंटिन्यू करते हैं. ठीक है,
Okay sir.
Allah Hafiz.
Allah Hafiz.